Okay, in the last video, we looked at how to balance some relatively simple redox reactions. In this video, we're going to look at more complicated cases. Cases where we're not just simply dealing with metal ions, but rather things like oxides of metals that can be a little bit more complicated because there's now other atoms that are present that have to be accounted for. So let me give you an example of what I'm talking about. Let's say that we were to take iron 2 plus and then react that with dichromate. Dichromate is Cr2O7 with a -2 charge. Okay, that's going to wind up producing iron in the +3 oxidation state plus chromium in the +3 oxidation state. Okay, and I think that looking at this equation here, you can see how this can be fairly tricky, mostly because there's not even the same, we don't even have the same elements present on either side of the equation. Obviously, the oxygens that are in the dichromate have to wind up going somewhere, but where, and how do we do this? The other thing that I want to point out is that in order to balance an equation like this, there's one other piece of information that we need to be provided with, and that is what are the pH conditions. We're going to say that this particular reaction is in acidic solution. Okay, the way that we balance these depends on whether or not they're in an acidic solution or a basic solution. We're just going to look at the acidic solution first. Okay, now the way that we tackle this is very much like what we did with the previous cases, where we break it up into two half reactions. Okay, so we have our reaction for iron, which is going from iron 2 plus to iron 3 plus. So we're going from iron in the +2 oxidation state to iron in the +3, which means that we are getting more positive, which means we must have lost an electron. Okay, so just one electron because, well, we've only gone from +2 to +3. Okay, this is going to be our oxidation reaction. Now, the dichromate is being converted to chromium 3. Okay, now trying to figure out how many electrons are being transferred here is going to take a little bit more work. In fact, I'm going to take a second here to just really hone in on how it is that we figure out the oxidation state of chromium here. So we'll just do kind of an aside over here on the. Okay, so we have Cr2O7 2 minus. Okay, one thing that we know, well, a couple rules that we know, is that oxygen is going to have an oxidation state of -2. Okay, these aren't, or this is an exception of oxygen, so this is going to be -2. Chromium, we're not sure of because it's a transition metal, but we do know that the overall, or I'm sorry, that the sum of all the oxidation states has to be equal to the overall charge on the compound. So here we have 2 chromiums, so we're going to put a 2 Cr plus 7 times the oxidation state of oxygen, which is -2, is going to have to add up to -2. Okay, so 2 times the oxidation state of chromium minus 14 equals -2. We add 14 to both sides. Okay, we wind up with, let's see here, 12. So the oxidation state for chromium is going to be +6. Okay, so we're going from the +6 oxidation state to +3. Now, The next thing we need to do here is figure out how many electrons must be getting transferred here. Okay, so each chromium is going to have, or is going to be in its +6 oxidation state. There's 2 chromiums there, which means we need to have 2 chromiums over here. So each chromium has to gain 3 electrons. And if each one gains 3 electrons and there's 2 of them, that's a total of 6 electrons. Okay, so chromium is gaining 6 electrons. Okay. Now what we're going to do is we're going to add these 2 equations together. Oh, we can't, can we? First we need to multiply the iron reaction by 6. Okay, that's how we'll get the number of electrons to equal one another. Okay, so now we wind up with 6 electrons plus dichromate plus 6 irons, yielding 6 iron 3s plus 6 electrons plus 2 chromiums, 2 chromium 3s. Okay, we can see here that our electrons cancel out. We're left with a dichromate plus 6 iron 2s, yielding 6 iron 3s plus 2 chromium 3s. Okay, we can see here that most of the atoms balance out at this point, except for the oxygens. Okay, the way that we balance out the oxygens is that we add water to the opposite side of the equation. So since we have the oxygens on the reactant side, we need to add water to the product. Now, how much water? Enough water to account for all 7 oxygens. So we're going to add on 7 waters. Okay, now this might seem counterproductive because now we're actually adding hydrogen as well. So there needs to be a way to balance the hydrogen out. So on the other side of the equation, we're going to add H+. Okay, and that H+ then is going to account for the H's in the water. So we have 7 water molecules, each with 2 hydrogens. That's a total of 14. So we need 14 H+. And what we wind up with here is our balanced equation. Okay, in the next video we're going to look at how we balance reactions that are in basic solution.